Alright, we're going to start section 5.5, talking about roots of real numbers. Taking the square root is probably what you're most familiar with right now, but there's actually more than that. You know, there's taking the cube root of something, there's actually taking the nth root of something, so of a number. Alright, we want to kind of go over those rules right now to make sure that we understand them. So just first of all, the first one is the definition of the square root. If a squared equals b, then what that means is the definition of a square root is the square root of b then would equal a. So that's the definition of a square root. So if this, then this must happen. Okay, that's what this means. All right. Well, similarly with that, if we put it in the nth form. If we take a to the nth power would equal some number b, then the nth root, which goes in the symbol, the square root symbol, that the value would go in there. The nth root of b then would equal a. Just some generic examples. Well, what would be if I were just to take what would be the cube root? Of 8 then? 2. Well, in that particular case, it'd be 2 because 8 is equal to 2 cubed, and then you cube root it, you just get 2. So that's the idea of the nth. So we have a table here, and then so just kind of understand the table. And when n is even or when n is odd, and then down your columns, this is when your b value is greater than 0. Or your b value is less than 0. So that's referring to this b value and this n value, when it's even or when it's odd, and when b is greater than positive or negative. Okay? So for example, when n is even and b is greater than 0, you're gonna end up having one positive root and one negative root. Okay? Alright, that's, for example, that situation, let's say that you had just the simple square root, that's an even power. That's the square root, there's a 2 right here, it's just we don't show it. The square root of 25. Well, normally, what we should be showing here is actually a plus and a minus 5. Okay, because what would happen is if we squared 5, 5 squared equals 25, and actually negative 5 squared is also equal to 25. So that's why we have to include both the positive and negative root there. Okay, that's where that comes from. Notice even, the n is even, and then 25 is obviously greater than 0. So there's an example there. Okay. Well, let's go down the road this way. We'll say our n is still even, but b is less than 0. So for example, let's say that I'm taking the square root of a negative 25. Well, in this particular case, there's no real roots. Okay. When we get into this case, we get into imaginary numbers, and we haven't quite gone over that yet. So we're not going to mess with imaginary numbers until a couple sections down the road here. All right. So there's no real roots to this problem. We can't we can't yet take the square root of that. Okay. We get into imaginary numbers. Right now we just want to stick with real numbers, real number roots. So in that particular situation, when this happens, you're taking the nth root, an even root of a negative number. There's no real number solutions to that. Okay. All right, we'll look down here. When b is greater than 0 and n is odd. So, well, that's just the example I just got done doing. The nth root is the cube root. N is odd, and then 8 is is greater than 0. The only real possible solution I have for this particular situation. Notice here in my chart, I said I only have one positive root. The negative root is not an option. Why is that? Well, remember when I said that 2 is my answer previously up here? Well, that's when if I take 2 cubed, what do I get?
8.
I get 8. But what happens if I took negative 2 cubed?
You get negative 8.
I get 8, yeah.
You get negative 8.
I'd get negative. I'd end up getting negative 8, and that's not what's in here, right? So this, my negative solution, I can only use positive 2 there. Okay, that's why I only have one positive root. All right, that's a pretty good example of that right there. Okay, so that kind of satisfies this corner of the chart here. Now going here. Okay, so b is less than 0. And n is odd. So what you'd assume, since we're taking the square root or an nth root of a negative number, you'd assume that there would be no solutions. Well, not necessarily the case, especially when when my n value or the nth root is odd. So for example, well, let's say that I'm taking the cube root of negative 8. Okay, so notice that my nth root here is odd. My value inside, my b value, is less than 0. That means it's negative 8. Well, in this particular case here, what value would work? Right? What value is going to work? What did we just say last time?
Negative 2.
It'd be negative 2. So in this case, negative 2 cubed is equal to negative 8. So therefore, my answer here is negative 2. Only negative 2. Positive 2 would not work because when I take positive 2 cubed, obviously I'm going to get positive 8, and that's not what's inside here. Okay? So notice that when this scenario happens all the time, not just in this particular case, but all the time when b is less than 0 and n is odd, you're only going to end up with one negative root. Okay? Obviously, the last entire property of this chart here is when you take the nth root, obviously, of 0, you're just going to get 0. That's pretty simple, hopefully, to all of us. So I have, on this particular problem, I have 16 x to the 6th, and I'm just basically taking the square root of it. Okay, so in this particular case, what I would suggest doing, on the plus and minus, don't necessarily worry about that. You know, that's just going to basically tag along with it no matter what, okay, your answer. All right? Well, especially when you're taking the even power, or the nth root is even, and everything in here is going to be positive or greater than 0, since this isn't going to be positive, because you're taking, whether it be x is negative or not, you're taking it to an even power, so that's going to be a positive number no matter what. So this will just tag along with that no matter what. So you know, square root 16, the square root of x to the 6th. Obviously, I have the square root of 16 is 4. And then the square, you know, this is where we're going to start getting in kind of a little confusion, I think. The square root of x to the 6th. Anybody have any suggestions on what that would be? Yeah, Brandon?
X cubed.
X cubed. Well, so, you know, and the reason why that is because x cubed squared is x to the 6th. Now, when I square root this, like this, you know, I could rewrite this thing as x cubed squared. Well, the square root and the squared basically cancel each other out, and you're left with x cubed. Okay? Now, my final answer is not just this, it's this. Because this tags along with it all the way down. Okay? Okay, so in this particular situation, I think they're just trying to confuse us, because we really don't have to worry about anything inside the parentheses. Okay? All we really have to worry about is taking the square root of this, you know, the power of 4 here, of this entire quantity. So again, remember, if I could write this inside as a power of 2, and then the power of 2 and the square roots would cancel each other out, then I'd be done, right? Let's see if I can't do that. Okay, so the square root of the quantity of q to the 3rd plus 5 squared. Does that make sense? squared square power of a power, if I would simplify this right here inside, I'd get this back right here, right? Well, notice what happens. The square root and this squared right here cancel each other out, right? So this x, I suppose if I just use a different color here, cancel out, and then I kind of squiggle that out. What I have left then is this quantity squared, but then I also have this negative sign tagging along the outside of it. That just keeps tagging along. Alright? Alright. So, I take the fifth root. I'm taking the fifth root of everything. So what I would like to do is write everything as a power of 5. And notice that I'm taking the square root or the nth root of a bunch of factors in here. So I can split that up into individual fifth roots. So what I mean by that is I can take the fifth root of 243 times the fifth root of a to the 10th times the fifth root of b to the 15th. Okay, and then focus my thinking on each individual one and simplify there. Okay, that's supposed to be a 10. So 243, I can write that as a power of 5. 3 to the 5th power. Now if I'm taking the 5th root of that the power and the nth root, they undo each other. Okay, they're like inverse operations. So therefore, all I'm left with right there is just 3. Okay, the nth root and the power of 5 cancel each other out. Now, I'm going to do the same thing here. Okay, I have the 5th root. I want to write a to the 10th as a power of 5. So what would that be? A squared to the 5th. Because notice if I take a power of a power, right, I'd get a to the 10th. But then the nth root and the power of 5 cancel each other out, so what am I left with? A squared. Okay, this is going to take some practice. See, some of you guys, your eyes are kind of rolling. B to the 15th. Okay, it's going to take some thinking, so I'd have b cubed to the 5th. Notice that that would multiply power of power would be 15. The nth, the 5th, the nth root, and the power of 5 cancel each other out. I'm left with b cubed. Okay? Well, again, my final answer turned out to be 3a squared minus b cubed. Take the square root of a negative number. Do we have any positive or negative real roots back? No. Absolutely not. There's no way. There's no, what we say on this situation here, there's no real roots. Now, once we start to get into imaginary numbers, we're going to start having imaginary roots, but no real roots. All right? It's actually not that hard of a problem to evaluate, because if you notice here, the nth root, undoes the power of 6, right? So you would think that you would end up just getting t here. Well, what's important, and this is an important rule, whenever you take if you take an even power, or you take the nth root, if you take the nth root of an even power, and it turns out your result is to an odd power, or t to the 1st, then what we need to do here is we need to include absolute value signs to ensure that our result would always be positive. Because if you notice in this, if you plug any number in for t here, in this expression, your result would always be positive. Okay, even if you plug a negative number in, it'll always be positive. Okay, so you need to understand that, for your result here, this needs to always be positive too. So to make sure to ensure that, we include the absolute value symbols in there. So my answer for this particular problem right here is not just t, it's the absolute value of t, and that's pretty important. And again, the rule is if you take the nth root of an even power, and the result is an odd power, which this is because it's t to the 1st, then you got to include absolute value symbols around that. Okay, that's a must. All right, that's it. Here in a second, I'm going to give you some try this problems and see how that goes. All right, so here's 5 try this problems. Okay, so try to complete these, see where we can get.